Okay, welcome to the study hall for April 10th. We just finished the rules, the usual warnings and such about what to submit, what not to submit, and so on. Today's theme is more flexible problem solving in Quant. That means it's going to be a lot like last week, a continuation of that same sort of thing. We're going to be using multiple choice questions and focusing on a variety of strategic approaches to those questions. So thanks for coming, and we're going to go ahead and get started. Once more, if you see a multiple choice question in front of you, this is where you find the multiple choice options. That's where you find them, right there. Okay, again, please don't answer in the chat box, please, if you just got here. Please answer in the multiple choice polling space, which is here. All right, all the questions in the part that follows are from the GMAT software. All of them are copyright GMAT, unless noted otherwise. Please note the distinction between gmatprep, which is the free software, and the OG, which is the paid book. The former is an absolutely acceptable source for study hall questions. In fact, it's the best source. The OG is not allowed as a source for future study hall. Okay, let's go ahead and do a problem here. How about let's see, how about that one? So again, make sure you know where to find multiple choice answers. Namely, well, that came out really good. Okay, make sure you know where multiple choice answers are found, which is right there. Okay, and here's a timer. Give this a shot. Have fun. Okay, let's all pick something here. Remember, this is a test where you have to pick something. When you do a problem, you can't not pick an answer. So if you, at least one person is on a tablet, which usually causes issues with things like polling and stuff. But if you're not, if your name is Tariq, or if your name is Butterday Gates, I don't know for sure how to pronounce it. And pick something. Okay, so we are pretty much all over the place on this one. Just to show you, almost no commonality to these answers here. So that's a little bit, that's a hard problem. So, okay, well, let's take a look here. So remember, the theme of today is flexible problem solving. The theme is solving problems in non-traditional ways. And again, as a group, we're kind of all over the place on this one, so we can definitely benefit from some sort of non-traditional approach. Can anybody think of a way to approach this problem that isn't what you would call traditional? Like, that's not algebra or whatever. Yeah, you can just pick numbers, right? Because, okay, plug in your own numbers, make sure you understand what this is, as opposed to back solving, which is also a thing, which is a very different type of thing. When we say plug in your own numbers, what we're talking about is making up a value for something essentially at random. So just make sure you know when you can and can't do that. When can you plug in your own number? Like, just, can anyone generalize about that? When is that a thing? Like when can you just make up your own values for something and not solve for them? Well, yeah, Ryan, it's closer to what Ryan is saying, because must be is not really the point here, because there are a lot of situations with must be where sometimes you have to solve for stuff when it says must be. Sometimes you don't. In a lot of those problems, you're right to a certain extent. In a lot of those problems, you're going to have to, you will have the ability to pick your own number. But it's more, I'm thinking more of what, it's closer to what Ryan is saying, except for still not totally. Because a lot of the time, when you're not given a number, you have to solve for it. So it's more like if you don't know, it's if you don't ever find out. So if you have, the point is if you have any quantities that are unknown and undetermined, that's when you can just pick them yourself. Not just unknown, because the problem isn't unknowns. I mean, in fact, the word unknown is another name for a variable. So in a lot of cases, you're going to just solve for a number. It'll just be a correct answer to the problem. But the point is that if you don't ever do that, that's when you can start just making up values. So just ask yourself, there are a couple of consistent signals when they are there. But you'll notice that in this problem, they're not there. Like people are talking about variables and the answer choices and things like that. It's true, if your answer choices are full of a variable, that usually means you can pick a number for it, but you can't depend on signals like that. And if you depend on that, then you're not going to figure this out. So basically just ask yourself, like when you look at a problem, try to judge without having to look necessarily for specific signals. Do I actually get a number as a solution for this? If you don't get a number as a solution, then you can just make one up. But if you do, then you can't. That's the point. So let's space that text out real quick. Okay, so if you look at this problem, it's going to be pretty clear after you think about it for a second that n is going to be any number at all that can do this. And the must be, as Anish said earlier here, the must be is definitely going to play some sort of role. Because what this means in this context, when we say must be, we wouldn't use these words if there weren't multiple cases of n. So here, that's a pretty perceptive observation here. These words imply that n can take on many values. Because otherwise we would have just said is, right? If n were some single number, then that means the reciprocal of n would also be a single number, and then we would just say it is in which of the following ranges. So yeah, Anish, it's actually pretty perceptive. Because it says must be here, you know that you're including multiple values in your consideration. So yeah. So the challenge is, how do you pick your own number here? So let's do that. Let's pick our own number. So let's think about how to do that. Anybody have any ideas? So let's try that. If you tried -1, so let's pick our own value. Well, if we try -1, then like for n, then the square of n is +1. That doesn't satisfy the condition. If you think about it here, what we got to do, I mean, let's break this down piece by piece. Let's take a look at the condition that they give us. This is the condition that we're provided. You'll see it load onto your screen here in a second. That's very big. Why is it so big? Okay, so here's the condition that we're given here. Some of this, they're just being obnoxious for no good reason that I can tell. I mean, if you look at these words right here, to the left of 0 on the number line, that's just kind of a weird way of saying that it's a negative number. So when you say -1, you got that part, but it's not any negative number in the world. It's a negative number such that the square does what you want it to. So the square of it is going to be less than 1/100. I mean, you may not immediately see right away, super fast, what kinds of numbers will do this, but at least you know that we're dealing with fractions. Because there's no other way you're going to get the square of a number to be so small. You want n squared to be really, really small, is what you want. So yeah, let's try fractions, right? So let's just try some really, 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 really small fraction or decimal. So maybe even a decimal, right? You might think about it either way. Right, let's just try that. Try n equals really small negative number. So like for instance, if n is, let's take Anish's suggestion, if n is -1/20, then n squared equals 1/400, which is a positive number. So this satisfies the condition. So this works. It's a thing. That means that n can be -1/20, but then, last but not least, don't forget what the goal of the problem is. The goal of the problem is not n itself. We had a few people picking c here, but that's not what you want to do. What you want to do is you actually want to find the reciprocal of n, which means you want to find 1/n. So, and then if you don't know that term off the top of your head, just put it on a flashcard or something like that. This means 1/n. So this is an acceptable value for n, which means that the reciprocal of this here, that's -20. So that means this. You would get this choice. Less than -10. Any questions about this? Do you have to try plugging in other values for n? Any thoughts on that? So in this particular problem, what do you think? How about in general versus in this particular problem? Like when you make up your own values, what do you think? So let's just talk about this. When you plug in your own values, in general, once you get something, do you have to check all the choices? Like might you have to plug in more values after the first one? Let's go ahead and use your polling here. Give me an A if you might have to plug in more values. Give me a B if no, you never have to. What do you think? Okay, so people who are answering this, yeah, you're pretty much giving me A for the most part. Of course, A. I mean, you're right here, but when people say things like, of course, there's this nasty way of... People who say things like, of course, or obviously, or something like that, for some reason they tend to be wrong about what they say a lot more often than you. But yeah, you might have to. When you back solve, you don't have to, because we'll contrast that when we get to a problem solving back solving. But just to make sure we're all on the same page with this, here's a really simple illustration of why you might have to. So let's say you had this question: what is x plus x? And then I'll just give you two multiple choices. A, it's x squared. You probably know that that's wrong. B, it's 2x. Okay, so the answer to this problem is definitely B, because x plus x is 2x. But just make sure you know under what circumstances you might have to plug more than once. Yeah, if you use 2 or 0, right? So if you plug x equals 2, if you are unfortunate enough to choose 2 or 0 for x, if you pick 2, then the answer is 2 plus 2 is 4, but then a is 4, and b is 4. The point is that if you stopped when you got to a, then you would actually get the entire thing wrong. And that's not, you don't want to get the entire thing wrong. So there. That's the point. I mean, so notice, just make sure you quantify the circumstances under which, because some people will waste their time plugging in again when they don't have to. Because notice the difference here, the reason you would have to plug again. So let's just finish up that process first. So if that doesn't work out, you just plug in another value. So let's just say you're going to plug 3 into the 2. So then the answer is 3 plus 3 is 6 instead of 2 plus 2 is 4. And then A is 3 squared is 9, and B is 2 times 3 is 6. So then you would win with B, and you would lose with A. And just make sure you understand, I mean, the example is very simple, but just make sure that you understand. Yeah, if you stopped at A with 2, then you would get the whole thing wrong. So the point is, make sure you understand the exact circumstances under which you should plug in again. Because some people would waste their time plugging in again on a problem like this, and you don't want to do that. You only want to plug it again if there's more than one choice that survives the first round. So if more than one choice is left after a round of plugging in, then you should plug in another case. But if you only have one survivor, you're done. Because people take this to heart a little too much sometimes and think they have to plug in another choice all the time, no matter what. And that's how this works. So, okay. We're going to look at an algebra solution. We're going to keep that brief because it's not the point of today. The point of today is the flexible problem solving. But yeah, I mean, we'll look at it, of course. So let's take a look at, does anybody have any other questions about this? If you have any other questions about this approach, please go ahead and type them in the box. Here's the problem again. If you were going to do this algebraically, so before we deal with 1 over 100, let's just take a look at a more mundane equation or inequality. Let's say if you had n, let's say you had x squared is less than 25, for instance. So make sure you know that you should know how to solve something like this, and you shouldn't have to go through an algebraic process to do this. Like this should actually be something where you can just get the solution, pretty much whip it out, whether it's intuitive or whether it's just by drilling it or whatnot. But what's the solution to that? This is the kind of thing, you shouldn't have to go through an absolute value with this. That's a little bit too much intermediate thinking. You should just you should be able to just generate the solution to this by thinking about it. And we got a number line here. It's not is -5 or 5. It's not an equation. It's an inequality. I mean, you want it to be less than 25. So careful with your, like, I guess those are the right boundary values, but we're not solving an equation, we're solving an equality. Okay, so if we have this number line here, what you want to think about is the fact that when you square a negative or when you square a positive, you end up with a positive square. So if you want to keep a square within a certain range, then you have to keep it from getting too big on either side of the number line. So to keep a square from getting too big, you can't let it get too big on the positive side. But you also can't let it get too big on the negative side either. So here are your, these are the two numbers that will actually give you 25 if you square them. This will give you 25 if you square it, and so will this. So if you want to keep the square under 25, then you're looking at the part in between these two dots. And the two dots themselves are actually going to be hollow because, visually speaking, in other words, you don't want the actual values of -5 and 5 because they don't, they're not less than or, those would be equal to 25, they're not less than 25. So now if you think about it with a fraction, there's another lesson for you here, which is that a lot of you guys probably think about 25 much more easily than you would think about 1/100. So you might want to think about something like that first. Like if you are confused by a situation involving weird numbers, then think about the situation with numbers that are less weird first. You know, like if doing this with 1/100 confused you, then don't think about 1/100 right away. Just think about 25 and then go back to thinking about 1/100. So now that we have that up there, we know that if x squared is less than 25, then we know that we need x to be strictly between -5 and 5. So now we can tackle this much more efficiently. If we know x squared has to be less than 1/100, it's the same thing. It's between negative square root and positive square root. So that's going to be between -1/10 and +1/10. Now, the only thing you need here is the additional restriction that x has to be a negative value. So you just cherry pick from here the values that are negative. Now, you don't need to do any math to do that. You just pick the values from here that are negative. So out of that range, the only values that are negative are the ones that are still not as negative as -1/10, but are still negative. So it's anything in that range. How about that? Okay. Any questions about this? Go ahead and post them in the box. If not, we'll move on to another problem here in a second. Cool, Fernando, thanks. Appreciated. Okay, let's take a look at this. Give it a shot. Okay, there's only about 10 of you guys that have answered this yet. So the next 30 seconds or so you can come up with something that is something. Remember, you can't skip questions. You can't not answer them. There's only something. There's only so much of an extent to which I can enforce that here, but you need to enforce it on yourselves. So please pick something in the next little bit. Okay, Izzy, sorry, remember where multiple choice questions are, where multiple choice answers are found here. They are found, let me grab that graphic for you. For some reason, this is like the biggest file on earth. This is where you find multiple choice answers to the questions. Once it appears on the screen, I'll just size it down. Okay, that's where you find multiple choice question answers. Not in the chat box, please. Okay, let's take a look here. Well, so this problem was clearly trouble. We are pretty much all over the place with it. So let's take a look. Do you want to talk about how they approached it? Do you want to say anything about it in the chat box? Okay, so you can factor stuff out. Yeah, because if you factor stuff out, you're still going to be dealing with a pretty similar situation. You know, you certainly can factor stuff out. But even if you factor out a 2, you're going to be facing the same sort of issue. You're going to get a 2 out, but then it's still going to be 1 plus 1 plus 2 plus 2 squared plus stuff all the way to 2 to the 7. So this is a thing. I mean, you can do it. Like, this is a valid step. But once you do it, you're still facing the same situation. So you can make the, okay. So now let's talk about what happens when we do one little step here. So let's see here. So let's take this expression that we're dealing with, and let's just look at pattern recognition. Because one thing that is a limitation is, I mean, ironically, people think it's a strength. But one thing that is more limiting than anything else is that a lot of people feel like they have to do things that are always rigorous math steps all the time. Which, in the case of something like this, you can just explore it and kind of see what it does. I mean, one thing, when you look at a problem like this, I mean, the GMAT really doesn't like busy work. Really, it doesn't. And one thing you'll notice about these problems is that none of them really require tons and tons and tons of labor. So once you see a problem like this that has, I mean, this is clearly more steps than GMAT would really want you to have to do. So whenever you have a situation with many similar steps, you should look for a pattern. And I mean, the exploration that can lead you to that kind of pattern is just, it can be sort of random, right? Sure. So like here, if you look at just this 2 plus 2 here, then that's going to be 2 times 2, which is, that's 2 squared. So then let me move this down here. Okay. So now what we're dealing with is that, right? So if we take this again down here, so that those first couple terms we can take out and we can replace them with another one of these, 2 squareds. Let's make it the right size. So now that's what we're doing, right? We took the blue part out and we replaced it with 2 squared. Sure. But then you can do the same sort of thing now. And then let me just color match that just so that people can know what I'm talking about for sure. So what we're saying is basically that this is now this. But then you can do the exact same sort of deal with these 2 guys. Yeah. Because that's going to be 2 times 2 squared, which is going to add another power of 2. So that's going to be 2 to the 3rd now. That 3 over there isn't supposed to be there. So now what you've got is the same sort of thing again. Yeah. And what you'll notice really soon is that you're going to keep seeing the same pattern over and over again. So when people are commenting so easy, I mean, there's not really a lot of value to be had from a comment like that. So you might want to not really go there. I know that every problem that you face is a respectable opponent. You should accord them all the same degree of respect. Like you would in a sport like boxing, you know, no matter who your opponent is, you don't want to not take your opponent seriously, because then they might knock you in your butt. Happens here, yeah. It's definitely a thing. But even so, I mean, even having that thought of, oh, it's so easy, there's literally no value to be gained from having that thought. I mean, it's obviously not that easy, because, I mean, almost everybody missed it right along with you. So really, you got to just eradicate thoughts like that from your head. They add no value. So in fact, they subtract value by creating a state of mind that's not really what you'd want. So eventually, the same pattern is going to continue. The point, my real point is this. My point is, do you have to understand why this is a pattern? Absolutely not at all. So pattern continues. So the point here is that when you explore patterns, just explore them. Don't worry about why the pattern exists, and definitely don't worry about deriving it algebraically. So, like, don't worry about why the pattern works. Seriously, people don't. And also don't worry about deriving it in some sort of formal way. I mean, it's going to work. I mean, one thing that GMAT will not do is give you fake patterns. It's not really ever going to happen. Like, they are on the level about a lot of things that they do, including that. If they give you a pattern, it's going to genuinely be a pattern. So we can just trust this is going to keep going until we reach the end of the problem. There's no fake patterns here. So if you do this, eventually you're going to end up at 2 to the 8th plus 2 to the 8th. And that's going to be 2 to the 8th plus 2 to the 8th, and that's 2 to the 9th. Now that's A. Do I copy the problem? Definitely not. That would be, I mean, that would take probably 30% of the time that you have to take the test. I mean, that would take an incredibly long time. I don't know why somebody would do that. I mean, if you have an arithmetic step to do, then it would be justified, but copying the whole problem. Like if you mean this problem, sure, because I mean, writing this down would only take a few seconds. But if you have a lot of stuff in the problem, then, I mean, if you're going to be manipulating an expression, then of course you should write it down. If you're going to be working with something, then, like, whatever is actually the material that you're working with, you want to have it in front of you. But do you want to copy the whole problem? Probably not, unless it's something like this. Okay, any questions about this? The point of this approach being that you can just explore it. All right, I like that. Let's take a look at Peter number 2 here. So let's take the problem over the next page. Now we're going to do that too. In fact, that's kind of why this problem is on here in the first place. But first, let's take a look at what Peter number 2 is doing. Here's Peter number 2. So instead of staying with powers of 2, I mean, I don't love the exponents any more than you do. So let's explore the pattern using numbers. So the thing is, you got all these powers of 2 here. And these powers of 2 are real numbers. These are not crazy voodoo symbols. I mean, they're just normal values. So we can explore them the way that we would explore anything else that involves numbers, right? So this is going to be 2, this is another 2, this is a 4, this is an 8, this is a 16, and so on. So the first few terms, if we look at what happens there, forget the exponents, you don't necessarily even have to think about them. That's 4. And then we still have this. And then if you're going to, the same pattern is going to happen to you, right? You're going to notice that this is going to be the same as the next term. So this is going to be an 8. And then after that 8, you're still going to have the plus 8, plus 16, plus etc. And then so on. So if you keep doing this, you'll end up with 2 of the last term. Now, let's take this for a second and just think about where we could have gone with this. So let's take these things from, dump them onto the next page. I mean, where can we go with it? As long as we're getting started doing something like this, we can actually just do what? Yeah, we can totally just add these all up. I mean, yeah. Let's just get out the shovel and dig. I mean, in fact, this problem doesn't even involve that much digging. You know, if you guys remember the last study hall, there was this problem which looked like it would just involve a completely insane amount of arithmetic. But then when we just sat down and did long division, it really wasn't that bad. What I'm going to do is upload that page. While we're working on this, I'm going to upload that to the next page so that I can remind you guys of it. It's going to be a big file. It's going to take a while to load. But there are a lot of problems on this test where if you psych yourself out of just doing the work, then you're not going to do it. But if you just, if you just put your doubts aside and just sit there and get out the shovel, the proverbial shovel, and dig, you'll be fine. Like, in fact, you can probably see it here on this slide right now. If you remember this problem from last time, this was from the previous study hall. This was the study hall of March 20th. So if you were there, you'll definitely remember this problem because a lot of people were like, oh my gosh. But this is from last time. I mean, this kind of problem, if you sat there and tried to talk yourself out of doing long division, you would definitely succeed in talking yourself out of it. But if you just were like, you know what, I don't know how the heck else I'm going to do this. I mean, if I saw this problem, I wouldn't know how the heck else I would do it. Just to start doing the work. And if you did it, it turned out to be really nice work. So just do it, and if it takes too long, quit. And honestly, guys, it's not going to take that long very often. Because they really want pick up the shovel and dig to work. So let's do that here. And again, here's what I want you to notice about this. I want you to think about this from the standpoint of the people who make the problem. If they wanted to absolutely force you into pattern recognition, think about what this final exponent would have been. And that's only 8. I mean, they chose this problem to end at 8. Okay, not 3, and also not 1,000. Let's think about why for a second. I didn't want to end it at 3 because then it would be too obvious that you could just do it. Like you wouldn't have to actually overcome a psychological barrier to get out the shovel and dig there because there wouldn't really be much of a hole to dig. So they don't want, I mean, they really want you. Like, if you're going to psych yourself out, if you're going to talk yourself out of doing the work, then they want you to. Because that's part of what they're testing here. They're testing whether people will just do the work versus whether they won't. So that's actually part of what they're doing with this test. But then what's more important is this. They gave you a small enough number that you can just do the work. If they wanted to force pattern recognition, they just as easily could have chosen a larger exponent. But they don't. They want you to be able to solve the problem in more than one way. They really do. This is the thing that is very consistent about this exam. When you look at answer keys in places like the official guide, you're not really going to see this too much, because the official guide is not in the business of giving away the flexible problem-solving method. That's not what the official guide is for. But they really do want you to be able to solve these in multiple ways. So let's just get out the shovel and dig. Let's just do it. So it's 2 plus 2. So let's take this thing over here again. Here, let's copy it and paste it. Okay, so this is 2. This is also 2. This is 4. This is 8. This is 16. This is 32. This is 64. That's 128, and that's 256. Also, don't forget the answer choices here. The answer choices are really far apart. So here are the answer choices. I mean, these are absolutely nowhere close to each other. So if you're fast at arithmetic, like if you can add the numbers fast enough, then you should probably just add the numbers up exactly. But if you're not, if you're slower, then you can notice how far apart the answers are. So then you can just estimate. Either way, so if you look at this, I mean, this is about, if you add these together, 256 and 32 makes about 300-ish. So let's color code that. This and this are somewhere around 300. So these two together. And then these two together are about 200. So then the other ones are really small. So it's 300 plus 200-ish plus like really tiny stuff. So about 300 plus about 200 plus small stuff, which is about 500. So then you'll notice that 2 to the 8th is about 250. It's approximately, it's 256. So that means that 2 to the 9th is about 500. So you win. And then all the other choices are 1,000 or more. I mean, so you can just do this. You can totally just do this problem by getting out the proverbial shovel and digging. And my point is to get you used to that as a thing. Because a lot of people are still very, very, very surprised by this when they discover it. But they engineer the test specifically so that this is a thing. Be aware of it. So I like this problem a lot because it's pattern recognition. Even if you're doing it with as algebraic an approach as possible, it's still, at the end of the day, pattern recognition. Unless you actually go through all the steps, like unless you just don't see what's happening until you get to the end. Even if you do algebra, you still have to recognize the pattern. You have to recognize how the series is collapsing on itself to give you a larger exponent. So it's pretty sweet. It's a cool problem. Any questions about it, feel free to put them in the chat box. And again, don't be afraid of get out the shovel and dig. If you don't remember this problem from last time, then watch the recording of last time because it was pretty cool. But compared to that, this is not a lot of digging with the shovel. Still, people talk themselves out of it. They do. Oh, that would take like 10 minutes. Well, no, I mean, you should just try it. It definitely won't. It won't take as long as people think it will. As people think they think it will. Okay, no one is chat boxing, so let's try this problem. Here's the timer. Give it a shot. Okay, still a lot of people who don't have an answer to this, so go ahead and pick one, please. Give you about 20 more seconds to pick an answer. Okay, so again, if you're a roommate or to read, and your roommate just pick something, you gotta pick a thing that is a thing here. We're pretty much evenly split as a group on this one. Among the first three answers, almost exactly even responses here. So. Okay, well, a basket contains 5 apples, of which one is spoiled and the rest are good. So, let's take a look. So how can you do this in a way that's not strictly probability theory? Let me have an approach. Think about how you first learned about probability way back in the day. Well, if you, okay, the whole 1 minus not spoiled. You could do that, although let's just talk about the most basic approach possible. I mean, these are pretty tractable numbers. These are pretty small numbers. You've only got 5, and you're going to pick 2 of them. There's not really a lot of different ways to do this. So if you are not absolutely sure about your calculation, then you can just list out all the possibilities. It's basically just getting the shovel out and digging again. Because I mean the problem with this kind of approach here is not really a problem. But if you do this, you're going to wind up doing exactly the same sort of calculation you would in the original problem. Like this is a useful tool if the opposite event is a simpler event to consider. So, like this approach would be excellent if the opposite situation were if the opposite situation were easier to calculate, then this would be great. But it's not. In this situation, the opposite situation is pretty much the same type of thing. To be precise, the opposite situation is the 3 apples not selected include the spoiled one, which is, in essence, the same thing we're doing here. So there's no value really to be gained from this kind of approach. I mean, in some problems, you can the opposite situation is a much easier thing to calculate, but not so much here. So, but let's just list this all out. Because I mean, if you're toying around with approaches like this here, well, I mean, to be perfectly frank, if you're messing around with approaches like this here, it means you don't really know what's going on. Which is fine. I mean, there'll be a lot of problems where you don't know what's going on and an exploration happens. But in this kind of problem, you shouldn't waste too much time exploring, because if you do not have a way to calculate this pretty much out of the gate, then this will always work. You will always be able to just list out the possibilities. So let's say the apples are numbers 1, 2, 3, 4, and 5. So you want to list out all the ways of picking 2 of them. Okay, well that's not very hard. You can have 1 and 2, you can have 1 and 3, you can have 1 and 4, you can have 1 and 5. You can also have 2 and 3, 2 and 4, 2 and 5. You can also have 3 and 4, you can have 3 and 5. And you could finally have 4 and 5. So let's get those up there a little bit more. Okay. There. Let's move this text up. Yeah, that's not too bad. Not too bad at all. So out of these 10 ways, now let's just say the spoiled apple is number 1. Okay. Well, let's say number 1 is the spoiled one. So in that case, these are the 4 that we want. We want these 4 out of 10. So literally 4 possibilities out of 10. So 4 out of 10, which is 2 out of 5. That's it. That's kind of all you have to do here. And we'll take a look at other approaches here. But the deal is, again, probability is not the kind of thing where you want to be sitting on an approach. Really, it's not. I mean, if you don't know exactly what you are doing pretty much right away, then you're good to go. Just make a list. You're just picking 2 things out of the basket. So picking 2 and 1, I mean, if you do that, Peter, it's going to work out the same anyway, but picking 2 and 1 is the same as picking 1 and 2. So if you were doing that, if you were considering the sequence in which you were picking these apples, then you would roll like that, but not so much otherwise. Looks like Francis, looks like you typed half a question there. So let's take a look at some other approaches while you're typing this. Let's run through. If there were a replacement, then you could still list everything out, but then you would have to list them in order. Like you would have to actually, if you were to take one and then put one back and then take another one, which would be kind of a weird thing to do, but then you would have to list like 1, then 2, and 2, then 1, and 1, then 1. You have to list those things separately. So you could try that. You could try that in your own shot. I don't have any idea how you would use factorials here. There doesn't seem to be that kind of thing to me. But those formulas and factorials, I don't really know those anyway, so it's, you don't have to really know those either. Peter, that's something you can think about when you judge the situation. I mean, you're just picking 2 things out of the basket, so. Again, if you make order matter, it'll just be a more involved calculation, but it should be clear that order doesn't have to matter, because all you're doing is selecting 2 things from the basket. All right, let's do this using multiplying probabilities. This is a more traditional approach. But again, if this does not make instant sense, you should just list out the possibilities. So remember, when you don't forget when you multiply probabilities, order is always taken into account whether you like it or not. So if you do any sort of approach involving multiplying probabilities, order is always taken into account. So, yeah. So here we have to do that. We have to account for order. So, well, what do we want to do? So there are two ways we can get the spoiled apple, which are, one, we can pick it first, or number two, we can not pick it first and then pick it second. Okay, well, what's the probability of number one? Like, what's the chance that we pick the spoiled apple first? That's just going to be 1 out of 5. So that's going to be, I don't know, SG. Oh, okay. No, you're doing spoiled and good. That's just 1/5. Here, this is going to be the chance of not picking it first is going to be the 4 non-spoiled ones out of 5. But then out of the 4 that you have remaining for the second choice, one of them is spoiled. And it turns out that these are just gonna cancel each other anyway. Those are some seriously big circles. Let's make those narrower. So that's going to be 1/5 as well. So there. So and these are mutually exclusive possibilities. So your total probability is 2/5. And it's a thing. It's not 4 out of 4, 4 or 4 cancel, you're saying, Angelica, you're saying those are cancel things. So that works as well. But you can pretend you are picking one after the other, yeah, because if you do multiplication of probabilities, then you absolutely have to do that. Because remember, whenever you multiply probabilities, you are always imposing some sort of order on the situation. So can I repeat point 2? What do you mean point 2? Karthik, what do you want me to repeat? Karthik, are you there? You asked me to repeat something. I'm not sure what. Okay, but yeah, guys, when you do multiplying together probabilities, whether you like it or not, you are always imposing some kind of order on the situation. Always. You always are. It's unavoidable. Because, I mean, you have a product of individual probabilities, and you have to formulate, because the fractions themselves appear in some order, the order of those fractions corresponds to the order of the choices. I mean, you can't write these fractions on top of each other. So that means that there is an order inherent in this, whether you like it or not. How do you undo it? Peter, I don't really get what you're asking. It sounds like you're answering your own question. It sounds like forgetting that is the common mistake. So it seems like you're answering your own question there. If you're not, then maybe you could ask me that in a way that's a little bit more clear. Okay, but again, I mean, if you, this you can't. It's impossible. I mean, that's what I'm saying. Like when you formulate a product of probabilities, you have to write the product in an order. And as soon as you have a fraction and then another fraction, you have imposed an order on the situation. That's the whole point. I mean, you can't not do it. That's what you're doing when you write fractions in a row like that. There is an order. It is inherent. Okay. But if it was me personally, I would just go right to doing that. And this is a list. You guys should all definitely be able to make this list in less than 10 seconds. If you can't, that means you have to practice doing it. I mean, making lists like this should not be the bottleneck when you do a problem like this. If that is the choke point, that means you just have to practice it. So there you go. Let's try this one. This problem has a lot of words in it. You know what that means. Whenever there's a lot of words in the problem, that means you should take, not should necessarily, but you can definitely allow longer than the average time. So there are always people who think that you have to do everything in exactly 2 minutes, and that is a terrible, terrible way to think about it. So there. No. Okay, so everybody pick a thing here pretty soon. I'll give you 20 more seconds or so, because a lot of you don't have answers yet. So then pick something. All right, let's go ahead and finish this up. There still are a lot of you who don't have answers to this yet, but we kind of have to get a move on. And, you know, once you get to being this much time, what you need to do is be honest with yourself. Am I really getting somewhere or not? You know, because it's a balance, right? You don't want to give up too early, but by the time it gets to be this much time, you've got to just move on. So, well, let's take a look here. I'll give you 10 more seconds to pick something. 10 more seconds. If you have to guess, please guess. Okay, so let's take a look. There's a lot of words in this problem. So we've done a few sessions on word problems, but let me just give you a quick recap. If you want more details on this, then watch the sessions that correspond to it. But the best practice is, first, ignore all specific math. I mean, basically the idea here is when you make a spreadsheet in real life, the spreadsheet is empty. So you should do the same thing here. You should always organize it first. Then, figure out what's in the problem. In other words, if you were going to make a chart, then what would be the headings? Then, once you've figured that all out, you should physically organize the information. So let's do that, and then we'll add some more stuff to this in a second. So what's in the problem? Let's ask ourselves what's in the problem. Well, we've got take-home pay last year, and that was per month. And then we have the fraction of that, so that fraction is new. But then the take-home pay each month is the same thing, and this is still the same color. And then this one that was saved. So the money that she had saved at the end of the year. So that seems like another, it's not the same as the fraction, so we can give that a third color. Then that portion of her monthly take-home that she did not save. So, well, I'm going to color this green as well, because those fractions are going to be related to each other. Like these two things here are going to be fractions that add up to 1, because whatever fraction you do save is the rest of it compared to what you don't save. Okay. So, and then there's a 3 times relationship. So that's really all there is, because all the money that she saved last year is this color again. And then her take-home pay was what fraction of her take-home pay is this? So we really only have 3 colors here. I mean, it's probably really intimidating, but when you break it down, there's not really as much in there as you thought you would, as you thought there would be. So we've got take-home pay, and then we have monthly take-home pay. Monthly pay. And I mean, we don't even need to say the word take-home because there's no other kind of pay in this problem. There's no gross pay. So we just need to say monthly pay, fraction saved, and fraction not saved, which is 1 minus fraction saved. And then we have all the money saved. Okay, well that's not too bad. So here is how I would organize that. I mean, I'm just kind of doing this spontaneously here. I mean, this doesn't lend itself to making rows and columns, so I'm just going to make a table out of this. I'm just going to make a bunch of columns. So monthly pay per month, frac saved and not saved. And then we have saved last year. And then this is going to be a fraction. This is also going to be a fraction. I mean, that's a pretty primitive device, but there it is. It's a device. It's an organizational device. Okay. Then, after you've organized the information, you should note all relationships between or among these quantities. And then here's a good test of whether you've done this well or not. After this step, you should never, ever, ever have to look back up at the paragraph. Ever again. If you have to look back up at the paragraph, that's a failure of organization. Because if you, I mean, again, that's kind of severe, but that's the point, is for this to be sort of severe. Because the only reason word problems are harder than anything else is that math in paragraphs is a very bad situation. It's just not easy to deal with. So everything that's true, we need to just get out of that paragraph right now so that we don't ever have to look at it again. So what fraction, that means that fraction saved is going to be the answer to the problem. So we need to mark that as answer. Okay, so that's the goal. Then the total amount of money she saved is 3 times, so I'm going to add a column for not saved per month. Just because that is in there. I mean, that's this quantity right here. And then if you multiply this by 3, then you're supposed to get, if you take that times 3, then you should get that, is what they say in the problem. Okay. So that's what's going on there. And then I think that is pretty much it. So, okay. And then I guess I should also put a column in there for saved per month as well. So Let's hope it fits the screen still. It doesn't. Okay, I'm going to have to resize this stuff, so give me a second. I mean, on my scratch paper, this would just be a festival of scratching things out. That's kind of how it would work. But that's fine. You know, you can, your scratch work isn't supposed to be pretty. That's why it's called scratch work. Okay, so there's an organizational device. And I mean, do I have a lot of things scratched off? Yeah, all the time. I mean, totally. Not anything to worry about. Okay, so let's take this to the next page because this page is kind of a mess. So the point here is that you don't even necessarily want to do math. You don't even want to pick a strategy until now. Okay, so back up to our best practice here. This is the point at which you should pick a strategic approach, not until now. That surprises a lot of people. But you don't even decide whether you're going to do algebra or back solve or whatever until now. Like, this does not happen until right there. And what's interesting about this also is that if your first approach doesn't work, then you're not back to the beginning again. If your first approach doesn't work, then, you know, you're only back to the red line again. You're not back to the middle of nothing, square one. So, okay, let's take a look at this with our chart. As a test of whether our chart works, again, my criterion, which is a pretty unforgiving criterion, but the criterion is if we ever have to look at the paragraph ever again, then we fail. So let's not look at the paragraph. There, no more paragraph. All right, how can we do this without algebra? You can make up, yeah, let's start with, you don't want to totally make up numbers because you have choices that are numbers. So let's back solve, and we can actually do a hybrid of both of those things. So, I mean, let's back solve. But then, in addition to back solving, we can pick our own numbers for the quantities that we're taking fractions of. We can actually do both. So let's start with, I don't know, let's start with a quarter. Because notice that you don't need to pick a 60 or something like that, because you can pick pay per month differently. I'm not highlighting that because it's correct. I'm just highlighting it because we try it. You can pick this again differently when you pick a different answer choice. So that means if we're picking this, that means this is a quarter, and that this is 3/4. So I mean, let's just let the pay per month be 4, so that we don't have to do unnecessary work. Because then we can pick a different pay per month later. We don't have to keep 4 forever and ever, amen, as long as we all shall live. We don't want to do that. So, okay, that means we're saving $1 a month, and we're not saving $3 a month. So the amount saved last year would be this times 12. That doesn't work though, so 3 times 3 is not 12. It's 9. So the point is that in this situation, we're actually saving too much. Like we saved $12 when the goal was to save 9. So that means if you realize that and you realize it quickly, then that's enough to cross off 1/4 and also the fractions that are bigger. If you don't realize that in 5 seconds, then just forget it because it's easy enough to plug in another value. For example, I mean, let's say you didn't realize that. You don't know which way to go. Just guess a way and do it. So, I mean, let's say that we went to B. If you try B, then you'll get, well, then you can just pick 3. And then this fraction is 1/3, and this fraction is 2/3, which means you're saving $1 a month and spending 2. So you would still be saving 12 last year, but 2 times 3 actually would be, we would want 6. So that's even worse. Like now it's a larger discrepancy. So this is an even larger discrepancy. So go the other way. See, it's not that bad. I mean, don't sit there thinking about it forever. So let's try D. Let's just make it $5 a month. So then these fractions are 1/5 and 4/5. That means you're saving $1 a month and not saving $4 a month. 1 times 12 is 12. But then if you do your criterion here, it's supposed to be 4 times 3. That's also 12. So these things check. We win. All right. You can do that to things. What we don't have time to do right now is an algebra approach. I mean, there's going to be one, of course, but we're already almost 10 minutes over. So we gotta wrap this up here. But notice again, that I can black out the question here. I took the question off the screen and we lost nothing. Because once you are organized here, you should not need the paragraph. You shouldn't need it. So, and I mean, your organizational device doesn't have to be really awesome or beautiful. This is certainly not a beautiful chart. But it's functional, and that's, functional is its own kind of beautiful, right? So, all right, thank you guys for coming. I'm going to go ahead and stop the recording here in a second. So thanks for attending. The next study hall is going to be in 2 weeks. So good night and good luck. If you have any super, super quick business-related questions, feel free. Otherwise, see you next time.